forces acting on a control surface. In the previous section, we considered the momentum equation for the control value. We now wish to evaluate the net force on a control surface that causes this change in momentum. Let us do this by considering the control mass shown in this picture, which involves a pipe bed. The control surface is designated by the dotted line around this picture. Draw around the duct, the pipe. At the point where the fluid crosses the section boundary, the flow is perpendicular to the control surface. This picture, these places. The shear forces on the section where the fluid crosses the boundary of the control surface are assumed to be negligible. The shear force at the section where the flow crosses the boundary of the control surface are negligible. This figure 7a shows the velocities and the B shows the force involved here for velocity and force. The force R is the result of the external forces on the control mass except the pressure of the surrounding. We define all forces except the pressure of surrounding the pressure of the surrounding P0 acts on the entire boundary as shown in the picture, on the entire boundary except at the inlet and outlet where the fluid crosses the control surface. Pi and Pe represented the absolute at this point pressure. Pe and Pi absolute pressure. The net forces acting on the system in the x and y directions, Fx and Fy, are the sum of the pressure forces and the external force are in their respective direction. As shown in the picture, we have various forces. We can write the relation in the x and y direction for the momentum equation. Sigma Fx, inlet and outlet pressures, force, And in the y direction we have this relation pi r on x The proper sign for each pressure and force must be cos B used in all calculations. These equations can be written as the momentum forces relation m dot and in the y direction So if there is a single flow, we can write this relation. M dot A similar equation could be written for z direction. These equations are very useful in analyzing the forces involved in a control volume in analysis.